everyone. Let's see if my live is working or not. Okay, it's on live. Hello everyone. Let's see if my live is working or not. Okay, it's on live. Hello everyone. What just happened? Did my PC hang? Looks like it. My PC didn't hang. Did the browser hang? Let's see. My PC didn't hang. Did the browser hang? Let's see. My PC didn't hang. Did the streaming quality isn't that good. I think I need to fix that. How can I fix it? Hmm. 120 FPS. I think I should turn this one on for the best quality. Otherwise it might be hard for everyone to see what I'm writing in code. And the video bitrate, should I increase it? Let's see how this works. My PC didn't hang. Did the streaming quality isn't that good. I think I need to fix that. How can I fix it? Even though I have full volume, I can still barely hear myself. 120 FPS. I think I need to speak louder. Oh, is there any setting? Oh, it's actually full. I think I should turn this one on for the best quality. Increase it. My PC didn't hang. actually full on for the best quality. Increase it. Sending 2.9 Mbps. I think I can increase the bitrate. That should increase the video quality. How about 10,000? Oh, they're sending 10 megabytes per second. How about 9,000? Oh, 9 megabytes per second. Can I increase it more? What if I do 20,000? Oh, it's sending 21 megabytes per second. Does increasing this makes the video quality better? I guess I'll have to see to find out. And what? 50,000. I want to see how far I can go. It says that the streaming video bitrate will be set to 51,000, which is the upper limit for the current streaming service. 51,000. Alright, then that's what I'm gonna go for. 51,000. I guess that's the highest quality. I think my life should be providing better quality now. Yeah, the quality is quite good. I mean, let me see by writing some code if I can see that clearly. Then I'll know that the quality is better and perfect. Okay, I already have some code. Let's see if I can see that on the stream. Wow, it's quite clear. I can see everything clearly. That means everything's working correctly. Now we can begin. So, as the title says, I'm gonna solve some programming problems. And I'll try to explain as much as I can. This is for improving my explaining skill and also my English skill. English is not my native language, as you all have already guessed, so I'm trying to improve it. and I'll try to do this daily. That's gonna make me improve faster. Anyway, I don't want to do any commentary now. I want to solve some problems. So I'm gonna be solving this one, the blocks problem. Let me make the file for that. A C++ file. Let's create a new file. I don't need the temp file now. Let's save it and name this the blocks problem. I think I already have the blocks problem file here. The blocks problem. Or I can just open the file. I have tried to solve this problem before, but it didn't work, so I'm gonna try to solve this again. Let's try to read the statement one more time. I mean, I have already read this a few times. I think I have to read a few more times to completely understand what this is saying. I think I should read it out loud. Many areas of computer science use simple, abstract domains for both analytical and empirical studies. For example, an early AI study of planning and robotics, STRIPS, used a block world in which a robot arm performed tasks involving the manipulation of blocks. This is just a paragraph, nothing, no information related to this program. I think the information starts from here. This is just a story kind of thing. In this problem, you will model a simple block world under. Okay, it starts from here, I think. In this problem, you will model a simple block world under certain rules and constraints. Rather than determine how to achieve a specified state, you will program a robotic arm to respond to a limited set of commands. The problem is to parse a series of commands that instructs a robot arm in how to manipulate blocks that lie on a flat table. Initially, there are n blocks on the table, numbered from 0 to n minus 1. These are the blocks. N blocks. First blocks is 0 and then so on. With block bi adjacent to block bi plus 1. So this is bi and this is bi plus 1, bi plus 2, 3, 4, and so on. For all I greater than or equals 0, less than n minus 1. Okay, as shown in the diagram below. I've already understood the problem. It basically says I also drew a diagram for this. Way to solve this. I have a diagram. I think this is the diagram that I drew. What? Why something went wrong? I want my diagram. Do I have to make that again? Failed to fetch. Currently showing a previous version of your whiteboard list. I think reloading this is gonna solve the problem. How many people are watching? guess none. Doesn't really matter though. Come on, man. What's going on? It took so much effort to make that diagram. Now I have to do it again. Don't say that my internet is not working. This is no hope. Why is there so many issues with everything? Syncing failed. What could be the issue? I think I need to switch my account to this one. I hope that solves the issue. Even though this account doesn't have the diagram. Now it's asking for password. Come on, work. Forget that. There is another online diagram, online whiteboard, right? Which I can draw things on. Whiteboard online. How long does it take for it to load? Is this even gonna load anytime soon? Finally. No, I don't want. You know what? Whatever. 24 hours left to save your board. Okay. Alright. That's gonna work for now. Oh, the problem is here. So, I've already read the statement. Now, let me visually explain that to you and to myself. First, we have n, which is 10 here for this sample input. So n is 10. That means we have our blocks. These are called blocks. So we have 10 blocks, which is one is 0, another one is 1. I think it's better if I make a square and type 0 in it. That's more efficient. I can even move it like this. Now how do I erase stuff? Don't tell me I cannot erase. What I'm gonna do, I'm just gonna copy these and make 10 blocks. 1, 2, wow. I can even organize this nicely. If I add more and then copy the whole thing, I can get 5 more at once. What just happened? Didn't I copy everything? Yep. Perfect. Less work. 10. I think I need to make. I'll write this like this. No, it's bigger, and you can see that clearly. Yep. Now it's perfect. You are 1, you are 2, 3, 4, 5, 6, 7, 8, and 9, because it's 10 and we have blocks from 0 to 9. So we have all the blocks here, and then we simply have to do the operations. They have 4 operations in total. Like one is gonna ask you to move A onto B. This is gonna do some stuff which is explained here. Another operation is move A over B, and pile A onto B, and then pile A over B. So each operation is different and followed by some steps to complete the operation. Let's try doing the operation on this one. So the first operation is move 9 onto 1. Let's see the details of the operation. Move A. So A is 9 and then B is 1. I cannot see the rest of the words after that. I think I need to adjust it. I think I need to adjust it a little more. Should I make this bigger? That's not doing anything. Alright, I think everything is adjusted now. So move 9 onto 1. So this is 9 and this is 1, and we have to move 9 onto 1. What does that mean exactly? Where A and B are block numbers, okay, 1 and 9 are the block numbers, puts block A, which is 9, onto block B, which is 1, after returning any blocks that are stacked on top of blocks A and B to their initial position. I mean, there is nothing stacked here yet, neither on block 1 nor block 9. Okay, so nothing is stacked, so we don't have to return any blocks to their initial positions. We can just simply put block A onto block B, and it's gonna look kinda like this. Block 9 stacked on block 1, and our first operation is done. And next we have to do move 8 over 1. 8 over 1. Let's see what the steps are. Wait a minute. Okay, I'm back. So move 8 over 1. Exactly what they want us to do is where A and B are block number, okay? Put block A onto the top of the stack containing block B. So block A is 8, and on the top of the stack containing block B, so block B is 1, and we have to move 8 on the top of this stack because this stack is containing 1, and this they told us to put block A onto the top of the stack containing block B, which is 1. So it goes right here, but before we do that, there is something else we need to see, and there's still more to this operation. After returning any blocks that are stacked on top of block A to their initial position, so block A is 8, and we have to return blocks to their initial position which is stacked on block 8. There's nothing stacked on block 8, so we don't have to do anything. We can just simply move this one right here, and that's gonna do the operation. Now there is so move A onto B and move A over B has only a little difference, which is in here we have to return stacks from both block A and B, but here we just have to return the stacks from block A, not block B. So this is the difference between this one and this one. And then move 7 over 1. So 7 is this one, and the stack containing 1 is this, so we have to move 7 over this after returning the stack. So there is no stacks, so we can simply do this, and this is gonna complete the operation. Now again, move 6 over 1. So 6 is this one, no stack, nothing on 6. We can just move this one here. I have to erase that, or I think I can move this, right? Well, okay, then pile 8 over 6, that's new. Let's see what this is. Pile 8 over 6, pile 8 over 6, the last operation. So pile 8 over 6, they're both in the same stack. What do we have to do? Where A and B are block number, moves the pile of blocks consisting of block A and any blocks that are stacked above block B. I have to read that again. Where A and B are block numbers, okay? 8 and 6 are block numbers, moves the pile of blocks consisting of block A. Moves the pile of block consisting of block A. So the pile of block consisting blocks A is this, not the whole stack. I think this just starting from 8 to going up, this one. So puts the pile of blocks consisting of block A and any blocks that are stacked above block A onto the top of the stack containing block B. So the block B is 6. So do we have to move all this over 6? The blocks stacked above block A retain their original order when moved. we can see that block A and block B are on the same stack, and there is a rule for that. I remember that any command in which A and B, or in which A and B are in the same stack, or any command which A equal B, that means both of these are similar, like this is also 6 and this is also 6, that, and when they are both in the same stack, both are illegal commands, and we can just ignore the illegal commands. That means because 8 and 6 are on the same stack, this command is considered illegal, and we could just skip this one. We don't have to do anything for this one, like nothing, and move on to the next one. 8 and 5. Now 8 is here and 5 is here, not in the same stack. That means we have to do something at least. And what do we have to do? Puts the pile of blocks consisting of block A, which is 8. The pile of blocks is all these. And any blocks that are stacked above block A, which is 7 and 6, stacked on block 8. Onto the top of the stack containing block B, which is 5. So block B is this, and we just have to move it simply. Take this over here. Done. Now our stack world. What is the world name? Let's see. Block worlds. Our block worlds looks this right now. Let's do the last two operations and see if it matches the result. Move 2 over 1. Move 2 over 1. This one. 2 over 1. Puts block A, which is 2, onto the top of stack containing block B, which is 1. This is the stack. After returning any blocks that are stacked on top of block A, which is 2, no blocks on the stack, we can simply move this one right here. And what is the last one? Move 4 over 9. 4 is here and 9 is here, this stack, and we have to move 4 on the top of this stack, and then quit. All of our operations are done. Now let's match the result. So we have to see for every blocks in the block world. So there were 10 blocks in total, 0 to 9. Let's write this here, okay? 0, 1, 2, 3, 4, 5, 6, 7, 8. Wish I had a graphics tab. That way I would have. I mean, I could have written faster if I had a graphics tab, but I'm doing quite good with mouse. Anyway, okay. So in 0, there is a stack on 0, which is 0. This is also considered a stack. And on 1, we have 1, 9, 2, 4. 1, 9, 2, 4. And for 2, actually, because 2 is on top of this stack 1, so 2 doesn't actually have a stack of his own, so it's considered null for this problem. And 3 has 3, as you can see here. Yeah, it's matching. That means we did everything correctly. 4 also doesn't have his own stack world, so it's also considered null. 5 has his stack world. 5, 8, 7, 6. 5, 8, 7, 6. Matched again. 6 doesn't have the stack wall. I mean, already 4 of our stack is done, right? I mean, here, and you can see that only 4 is here. This 4 stack only. That means the rest of our blocks are null, obviously. We don't have to check for the rest. We know that we are already done here. Now that was the visual. I think we got the idea of what this problem is about. Now we just have to solve it in code. Okay, let's begin. Let's see if I have any viewers yet. Now how can I find my live? I'm gonna search my channel name, and it's right here. 37 minutes have been passed already. Wow. And we didn't even solve one. Now how can I find my live? I have to be more faster. I'm gonna search my channel name. I hope that this is day 1. I hope as days goes by I get faster. I've been solving problems for about 3 years now, but I've never done it live. I mean, I've never done live problem solving on YouTube. I took one session in Facebook though for our competitive programming club, and I took a live session, solved few problems, answered questions. I have to sign into live first. Yeah, obviously. Let's see how my live is working. And it's right here. What is happening? Why is there 37 minutes have been passed already. Wow. And we didn't even solve one. Now how can I find my live? I have to be more faster. I'm gonna search my channel name. I hope that this is day 1. I hope as days goes by I get faster. And this is also 6. That, and when they are both in the same stack, both are illegal commands, and we can just ignore the illegal commands. That means because 8 and 6 are on the same stack, this command is considered illegal, and we could just skip this one. We don't have to do anything for this one, like nothing. I think I need to improve my English a little bit. Not a little bit, way more. That's what I'm doing here. Onto the stop of the stack containing block B. So the block B is 6. I have my volume on full, but still I can barely hear myself. I think I need to speak more louder. That is one of my lackings, that I cannot speak very loud. Is there any way I can increase the sensitivity of my microphone? Anyway, I'll just speak louder. So do we have to move all this over 6? Okay, the block stacked above block is quite clear. Retain their original order when moved. Everything is. We can see that block A and clear. Block B are on the same Alright, that's enough. I want to solve the problem now. First we have to take N, but let's make the structure. Normally I just do this, but there's a shortcut that I already set up, which is if I type all and then press Ctrl J, it gives me this code blocks. You can set that by going to here, the editor, and then abbreviation. Here you can set that. I'm not going to explain that. You can just go through that yourself. Let's hide this for now because I need to do the debugging, and it's quite hard to do debugging with this on. So let's take N as input. LL means long integer. So this I have to take the operations as long as I don't hit quit. That means it's a while loop. It's going to be true until we hit quit. Now these are strings, obviously. So we have to take string input. Alright, let's declare a string variable called s. Let's take the input. But C in S is only gonna take one one word, and then when it encounters a space, it's gonna take 9 on a different string, but I don't actually want that. I want the whole line. So what I have to do is, I think, let's say getLine. I think I can use getLine. Let's see, S. Yeah, I think I used getLine for the previous version of this code. I kind of forgot what I used. But let's see. GetLine. Let's see if it's printing that. So even though I took the whole line as a string, I still have to what do you call it? I still have to identify each one into different variable, because we need to match our operations. To match our operation, we only need 2 words, which is the first and the third. Okay. So first we took the whole line as a string input, and then we're gonna individually take every words, and then we're going to put those in a vector. Okay, I mean in a index of a vector there will be 4 different word. What can I call this? I can call this store. Now how can we distinguish every words in this string file? Can I write S0, and is that gonna give me this first word, and S1 for the second, S2 for the third, and S3 for the last? It's not gonna work because that's not how this one works. If I type S0, what I'm gonna get is just actually I'm getting M, and this is just this one. I'm printing. Let's copy this, run the program again. So I'm not getting the first word, instead I'm getting the first character. But I need the whole word for each of these 4 individual word. We can get that by using a built-in function, I think, which is iString string. You can search the details on Google, how it works or what it does. So iString stream is gonna read S, and it's gonna give us every single word stored in that string. I think I need to use while cin. No, it's not cin, it's actually read word and cout word. Let's do inline. Oh, I need to, I'm using word string, but I didn't declare the string, did I? That's why there was an error. Now if I run it, it's gonna give me every single word which is inside this S string. Now we can use it, but we have to store every single word in the vector. So let's do that. Store.pushback word simply, and we are not printing that now. That was just for the debugging. now we can do our previous thing that we did. Like if I type store 0, it's definitely gonna give me the thing. What happened? Store 0. What? 10. It was working just now. What happened? Store 0. There's a problem with getLine though. I sometimes have to use this get character. Yep. We are getting our first word by just simply saying store 0, which we wanted. If we type store 0, 1, 2, it's gonna give us on 2. Yep. Now we can go on. I think for now I'm my top fan. Now we're gonna need that for selecting our operations. For selecting our operation, we don't need the numbers itself. We only need the name. Like move on to means this one. Pile over means pile over the last operation. Right. So we need if condition, obviously. So if store 0 equal move and store 0, 1, 2 equal on 2, that means the first operation. Okay, and our first operation will be here. Let's do for the rest also. I'm just gonna copy that, paste here, but it's if it's else if, not just if. If I only write if, it's gonna give me syntax error. So if store 0 if store 0 is move and then store 2 is over now, then it's the second one. And then for the third one, I'm just gonna copy this again. I'll copy it 2 times. Then if store 0 equal pile, store 2 is on 2. Now if store 0 equal pile and store 2 is over, I already have that word written. So this is for operations. Alright. Now for the block world, you might have already guessed that we need a data structure for that, for storing the block world. And the efficiency of the algorithm and the chances of us solving it depending on whether we can choose the right data structure for it or not. In my previous version of this code, I think I used vector and then queue, but that didn't work so well. Now I'm thinking of using list. I'm thinking of using a list inside a vector, because we have 0 to 9, and that's why I want to use a vector, and then inside the vector there will be list. That list will contain the stack. This stack. I'm gonna take a break now. I wanna go drink a glass of water because my throat is really dry. One of my lackings is that I cannot speak for too long, too loud. I'm hoping to improve that. pause the stream. Is there a way to pause? I think stop streaming is gonna stop the stream. That only hides my screen, doesn't actually stop the live. I'll just mute my microphone. Okay. Okay, let's keep it like this, and I'm gonna come back later. Alright, I'm back. Where was I? Okay, uh, I set up the operations, and then, oh yeah, we have to think of a data structure. Now, what data structure did I talk about using? It was vector and then a list inside vector, right? Okay. So we have to create our data structure outside this while loop, because this while loop is for getting the operations, right? Let's create a vector. I'm gonna call this block world. That sounds like a nice name. And then list of, these are integers, right? Let's take long. Oh, n is less than 25, so we don't actually need long, but I kinda always use long. I'm used to it. It doesn't really matter if we use long on the integer. So this is our data structure for our block world. I mean, inside that, what we have is this this thing we have inside that. Now, so we have to define a range from 0 to 9. We can simply type n. Because n is 10, it's gonna give us 10 index inside the vector, which will be in default 0 to 9, so we don't have to do anything here. Okay. Now, initially, let's draw that again. I'm gonna copy one of this thing and then paste it here, and then again. Did I get 10 blocks? Let's name this, and then we will find out. Well, the first one is actually 0. I think something stuck in my throat. 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't need you two. We can go. So initially, we have, even though it doesn't look like it, but still in each index we have one stack, but we didn't define any stack. We just defined the size 0 to 9, but there is nothing in those indexes. To visually show that, I would say that in 0, 1, 2 to 9 there isn't anything right now, but we have to make it like this. I don't know if I explained it correctly or not, but let's do it. Okay, for I, that is a shortcut for loop, and it's going to be 0 to n, and inside the I, so it's a list um, so do we push back? Yep. We can even push front because lists work both ways. I can push in the back as well as in the front. We're simply pushing back the same block. Like inside block 0, index 0, there will be block 0 and so on. Now by doing this, we're visually getting this. Okay. Alright, now that we have our data structure, we can do the operations on this data structure. I mean, we will be iterating through this data structure, this vector, this list, and doing the operations manually, or let's see how it goes. So inside the first operation, I mean inside every operation you need two variables, right? So why don't we take two variables and define them? We don't have to define them for every of these. We can just define it one time here. That's going to work for all the operations. LL. Let's call this A and B like they did. A and B. That will be much simpler to explain and work with. Inside A, we have, so how do we get 9 and 1? Simply store 1 and store 3 is gonna give us that. But one thing you should know, that we are not getting integer or long. We are just getting a word or character. But we have to convert that. I think we can convert that like this: s2ll, a built-in function for that. Yep, it's working. Make one for B. And that is 0, 1, 2, 3. Okay. So we got our A and B. Let's see if we actually got our A and B or not. A space B. So if we type move 1 on to 5, we should get 1 and 5. These are integer values, or long, same thing, but differs in size, so not exactly the same. But anyway, now that we have our integers, we can begin with the operations. Is there anyone watching me? Someone's, there's me. So for the first operations, where A and B are block numbers, puts block A onto block B after returning any blocks that are stacked on top of blocks A and B to their initial position. Now before we move our block A onto block B, we have to clear the stack, meaning everything that is on the stack goes to their initial position. Like 0 will be positioned here, 5 will be positioned in index 5. Should I write the indexes for you to clearly visualize in your mind? These are the indexes and they have the same value or stack, if you may. You know what, I'm gonna write that down for much better understanding. Stack. Now that explains it much better. Index and then they have stack. So before we move 9 onto 1, we have to clear the stack. Now how do we know where 9 is and what stack 9 has inside? Now I don't know if you already get that, but 9 is not always gonna be in index 9, right? Like look at that, there so many indexes will be null. I mean 9 can sometimes be like here, so you cannot always find 9 here or 4 here. They could be in other stacks, right? So how are you gonna find them? Now our constraint is really small, 25, so we can just iterate through that every time, like manually looking for the thing, looking for our target. For example, we are looking for 9. Suppose 9 is not in here. We're gonna look in index 0 and there's stack 1 and there's stack 2 and there's stack 3 and there's stack, and then we can find 9. Even if there are more stack, like here, we can still find 9 by iterating through every stack, like here, then go here, then go here, then go here. Oh, we found 9, got it. And then we're gonna clear the stack, like not the whole stack, but the stack that comes after 9, this one, also this one. 9 goes to their original position. Okay. I think that is well explained, considering this is my first time explaining in YouTube live. But I'm doing quite well, I think, but I'm taking way too much time, but I hope I improve. So we're gonna clear, so let's make a temporary state for our clear operation so that we can actually see that it's actually working. All right, I guess. Oh, we need something on top of 9 for the stack. I mean, you know what, let's remove 0 here. That looks like a good state for our work. So before we move 9 to 1, actually 1 should also have a stack on it. What if I put a 1 here? Actually, no. The last, I mean the first blocks should be there in their original index. I mean, there is no way for them to be in a different index than they should. I mean, if they're not in other blocks, then they should be in their original position. I think that's true for every operations. So we don't need to see this anymore. We already know that we have to clear the stack and then move this one to this one. Clear the stack for both A and B. Here A and B is 9 and 1. So let's do this. I'm gonna put this here. So how do we find 9? We iterate. Now to iterate the vector, simply we're gonna take a for loop which is gonna run from 0 to n, going through every index and visiting the list. Now if a index doesn't have a stack, that means the list is empty. So if stack world, right? Block world, sorry. So if block world is block world I mean the ith block world, list is empty. So ith block world is empty. That means we don't have to go inside. So if it's not empty, then we're gonna go inside, okay? And then we're gonna check. Now A and B is our target, right? So we're gonna check for A first. So if no, actually, now the list is not empty now. That means we have to iterate the list now. So iterate the list. You know that we cannot do index based iterating, index based iteration for list, can we? We cannot. We have to use an iterator for iterating the list. So it's pretty simple. Just we have to for auto iterator equal block world I dot begin. Iterator not equal block world I dot end. Iterator plus plus. That should do it. Is my code getting smaller? I think I can compress this a little bit because I don't need that much space for this diagram. I need more space for my code to show. So iterator, let's see if it's printing that correctly or not. See out iterator. Now iterator is not gonna print the value. To print the value we have to type something like this, a star in front of the iterator. Now to make this state, I think we have to do that manually, don't we? I mean, there is no operation. I mean, I haven't made any operations to make this the state look like this. Let's do it manually, okay? Block world 0. Do we have to push back? I think all right, let's push back. Okay, let's copy this entire thing because we're gonna need it so many times. You know what, I'm not gonna initialize any blocks on index. I'm gonna hide it for now. So block was 0 has nothing, right? 0 is empty. So let's move on to 1. 1 has 1 inside, so we're gonna push back 1. Now for 2, so I have that copied. What? Didn't I copy this? So block world index 2, we have to push back 23970 5 times. So we're gonna need it 5 times. Let's copy this 5 times. 2, 3, 4, 5. So 2, 3, 9 actually, 7, 0. 2 is done. 3 is empty. Moving on to 4. Copy this. 4 have 4 and 5. Copy this. Wait, give me one moment. I'm back. I went to bring a snack. I brought some peanuts to enjoy while I explain and solve this problem. Okay, I'm gonna put it here. Now 4 has 4 and 5. Yep. 5 is empty. 6 has himself inside. 7 is empty. 8 have 8 inside. 9 is empty. So we just manually created this entire thing. So if I do this, I think I'm gonna get this thing. I should put this one here. I'm not getting anything though. Oh, I see. Move 9. We got it. The exact same thing. 0 is empty, so it was skipped. 1 has 1 inside, I mean 1 stack inside at least, so it's shown here. 2 has 23970, 23970. 4, 5, 6 and 8 working perfectly. Those peanuts are quite crispy, and I like it this way. So we are searching for 9, right? So in some point we will be visiting 9, right? Then we will do the rest, like uh, resetting the stack from 9 to the rest. That means our work only begins after we find 9. That makes it easier. So if error is equal our a, that means we have to start working now. Now resetting means that we're gonna put, no, actually I mean in real life scenario we put 0 on their original position first, then 7, then 9. But here, because we are at 9 first, we have to move 9 to their original state first. These two guys will be floating in the sky, which cannot happen in real life though, but in programming it can happen. So then we'll be moving 7, then we will be moving 0. It's actually quite simple to reset them. Logically, what I'm gonna do is I'm gonna remove our 9, right? Yep. Okay, so I'm gonna remove 9, and then inside my vector 9th index I'm gonna push 9 inside the list, and then I'm gonna remove 7 from the list and then do the same thing. Let me just do it. Explaining is quite hard. So remove the index, block word I dot how do someone remove something from the list? I think again is clear. Not working. I think it's erase, right? I mean, I'm trying every possible word for this. Got it. Hmm. Something went wrong. Actually, I faced this problem before. When you try to erase stuff from the list while you are iterating, something like this could happen. And to solve that, I did something like this. Like iteration, iter equal this, and then um, I think it will be easier if I set a boolean, like a flag, that I found our target, and you will know. After I write the code, you'll know why I'm taking the flag. If we found this, we're gonna do flag equal true, and then if flag equal true, then we're gonna start deleting stuff from the list. That makes it much more simpler. Hmm. Oh, yeah. To delete stuff from the list, we actually remove this iterator from here, and inside the code we have our iterator, like iterator plus plus here, and then if we delete something, then iterator is gonna be this block world I dot erase iter. Because it's a list, when I remove this element, the link kinda gets broken, I think. And here I think it gives you the next link. That's why you don't need to do I iterator plus plus. Once you delete this link, you are already getting the link, the next link from here, and you're storing it from here. And if you're not deleting anything, you're manually going to the next connected node or link or whatever by this. I think that's the case here. It might be more, or it might be, I don't think it might be different, but there might be more to it. Let's see. Nine. Our command was on to 1. It's still printing this, aren't we? Oh wait. I think I should print that and print this here. One, two, three. Yeah. 1, 2, 3. Then we encountered 9, and then 9, 7, 0 are missing. Then we start from 4, 5. That means it worked. But we didn't added those to the initial position. Just simply do that here. Done. Okay. I was eating some peanuts. So this is done for A. Now we have to do it for B also. I mean, that means we have to copy this entire thing. Not just that, also for pile and this. I mean, for this operation we also have to do that. So let's just put this thing in a this thing in a function. Let's make a function with these few lines of code, okay? It doesn't have to return, is it? And the name should be initial state, right? That sounds good. It's gonna take our block world data structure, and I'm gonna pass this as a reference, because if I don't do this, this entire data structure will be copied into this function every time that I call the function. That's gonna consume more time. And I mean, not just that, but also I have to do the changes in this data structure, and those changes won't affect the main program unless I pass that as a reference in this function. So obviously I need that. And then what I need is the target. Simply, that's it. And then just copy this whole thing. Oh wait, also I need n, because for running this for loop I need n. Got it. Anything else I need? So I'll be needing this entire thing. This for loop ends here. So here, this entire thing goes right here. And I call the function. Now I want to return the initial state for A. I just simply call the function. Enter my data structure. Block world. Then n, and then my target, which is A for the first one, and then for the second one it's B. Quite simply, I'm doing both just with these two lines because the work is being done here. Let's see if it's actually working correctly or not. We don't have to go through this, we can just simply print our block world here and see how our block world looks. After this, our block world should look different. So to print our block world, let's also make a function. I'm gonna name this print world, and obviously I'm gonna take my data structure and just the n. Also, I don't need the n though. I can get the n from the length, right? And it's just the length of the block world. Yes, I'm gonna get the length. And then I'm gonna run a for loop. It's not n, it's actually length. And then yep, cout I, the index, and then for auto point list. I cout point. This is gonna print the world. Something's wrong. Oh, actually this is not A. I mean, it was A before, but now it's target. I mean, let's see how many A I have here. Oh, just one here, right? Target. What's that? Hmm. Oh, block world. I mean, this is the, yeah, this is the index. That shouldn't throw an error. Oh, actually, how can I do that to list? I have to push back. I cannot just insert a value like that in a list. 10 move 9 on to 1. I guess something's wrong. Oh, I'm just printing this airline for no reason at all. Ah, I forgot to copy that again. Let's see how our world looks. I think there is a problem in here. Here I can do one thing is after we are done initializing it, I mean, I'm done moving every block to their initial state, we can simply return, break. This is gonna break us from this for loop and then return off. Okay, instead of putting their initial state from here, instead of returning every blocks to their initial state from here, I'm just gonna store them in a vector and then I'm gonna return them to their state when I get out of the loop. Return state. Blocks. And then when I get out of the loop, I iterate through the return blocks and then return every blocks to their initial position, which is simply doing this: block world point dot push back point, and then we won't be needing this. That solved the problem. So that was the problem, right? Now let's see if our world is exactly how we wanted it to be or not. So after the stack of 9 goes to their original position, it should look something like this. Let's see if it's similar to this. So yeah, 0 has 0, 1 has 1, 2 has 2, 3. 3 is null, means nothing. 4 has 4, 5, 5 is null. 6 has 6, 7 has 7, 8 has 8, 9 has 9, exactly how we wanted it to be. That means our function is working. still have a lot of work to do. That is that is in the end. So after I'm done returning them to their initial state, what I have to do is I have to put block A onto block B. How am I gonna do that is first I'm gonna go to block. I'm gonna find the block B and then put block A on that. I think I should make a function for that because I might need to use that many times. So why not just make a function? I'm gonna call it put block. I'm gonna call it put A on B. I mean the function name is exactly what it does. It puts block A on B. Puts A on B. Yeah. We're obviously gonna need our data structure. Passed as a reference, and then we're gonna need block A and B. So to put block A, which is 9, right? On block B, which is 1, we have to find where 1 is. Let's find 1. To find, we can use this. I have to make some changes inside though. Let's take the whole thing and then we will delete what we don't need. Flag we may need. Return blocks, we don't need that. So we are iterating the vector. We don't have the n though, do we? I mean, why am I actually passing the n? I don't need to pass then. I can get n from the block world itself. Also, let's change n to length. Same goes here. And this is not n, this is length. Okay, a lot of work to do. So we are iterating the vector. Then if that block is not empty, we are iterating their list, as in stack. So yep, so if our iterator is equal, we're searching for B, right? That means our flag is true. That means we found our B. And we have to put 9 to the top of the stack. Now the stack might have something on top of it, or might not have anything at all. So let's do it for this scenario when it has something on top. So we found it here, but we have to go to the last point to insert something in it. So that's what I'm gonna do. So I'm gonna say flag equal true. So here flag equal true. I think I don't need these thing. Okay, so once I know that one is here, I already know its index because it's just I. So I can just break from the list iteration and simply simply put simply type something like this: block world I, which is this index, and then I'm gonna push 9 on the last index. Or you can say top of the stack or back of the stack, whatever. I'm gonna push back A, and that will do the exact same thing as, suppose we have something on top of block 1, and this is gonna do this exactly like this. So yeah, and then we can just break from this for loop also. This is gonna break from this for loop, and then we are done. So let's go put A on B. After returning their initial position, we're gonna do put A on B. Then let's see how the world looks. Let's just copy this, okay? Oh wow, extra spaces. Oh, we don't need the N now, do we? 10, move 9 onto 1. So I mean, after we put 9 on block A, our block world should look something like this. 0 is 0, 1 has okay, what? Oh, I think it didn't work correctly. Oh, there is no either plus plus. How silly. Such a silly mistake, but we are okay now, I think. Yep. Now this is after we return them to their initial position, and this is after we completely do the first operation, which is move A onto B. Now let's see. 0 has 0, 1. Wait, that doesn't sound right. Why it's on top of 9 though. It was supposed to be on top of 1, and 9 still has it. Oh, oh, actually, I didn't delete 9, but still, it was supposed to be on top of 1. Oh, so much stuff I miss. If the flag equal true, only then we do it. Not when flag is false. Also, I need to delete 9 from its original state. Yep, this one. Yeah, 0 has 0, 1 has 1, 9, 2 has 2, 3, 4 has 4, 5, 6 has 6, 7, 8, and 9 supposed to be empty, right? So let's just delete that. Block world A. Block world A should be completely cleared, right? I think so. Yep, completely cleared. No matter how many stack there are or one, it's gonna get completely cleared. Well, the code is getting bigger. 185 lines down. That is big. Still not finished though. So we don't need the prints right now. That's all for operation 1. Now for the next operation. So move A over B, where A and B are blocks number, puts block A onto the top of the stack containing block A after returning any blocks that are stacked on the top of block A to the initial position. Now we have to do the initial positions for A now. Simply, I'm just going to copy that. Initial state block world A. Alright, done. And then what? Put block A onto the top of the stack containing block B. Alright. Copy this and then paste it. Done. Now let's see if our block world is exactly how we want it to be. Print world, block world. We have to keep debugging as we go on, otherwise we might run into some big problem. So 10, move 9 onto 1. Then our world is like this. Then what we did? Then we did move A over B, right? Move A over B. Then let's see what I want to move. So move A over B. Let's move 1 over 4. Move 1 over 4. That should make our block world look like this. So 9 will be returned to their original state. Yeah, then 1 should be here, right? then our world should look like this. Let's see if it's the case. 0 is 0, 1 is empty, 2 has 2 3, 3 is empty, 4 has 4 5 1. Wow. 5 is empty, 6 7 8 9. Perfect, exactly how we wanted it to be. So our second operation was done very quickly. Only the first one took so long. I think the next two will also be faster, but cannot say for sure. Let's see, pile A onto B, where A and B are block numbers, okay, moves the pile of blocks consisting of block A and any blocks that are stacked above block A onto block B. That sounds like a lot of work, but we'll do it anyway. Is there anyone watching though? Where's the view count? Hey, where's my live? Oh, there you are. That's that. Move A over B, where A and B are blocks number, puts block A onto the top block world. We go on, otherwise we might run into some big problem. Keep debugging as we go on, otherwise we might run into some big problem. So 10, move 9 onto 1. Then our world is like this. Then what we did, move A over B, right? Move A over B. Then let's see what I want to move. So move A over B. Let's move 1 over 4. Move 1 over 4. That should make our block world look like this. So 9 will be returned to their original state. Yeah, then 1 should be here, right? Alright, then our world should look like this. Let's see if it's the case. 0 is 0, 1 is empty, 2 has 2 3, 3 is empty, 4 has 4 5 1. Wow. 5 is empty, 6 7 8 9. Perfect, exactly how we wanted it to be. So our second operation was done very quickly. Only the first one took so long. I think the next two will also be faster, but cannot say for sure. Let's see, pile A onto B, where A and B are block numbers, okay, moves the pile of blocks consisting of block A and any blocks that are stacked. Alright, that's it for watching myself. Where A and B are block numbers, move the pile of blocks consisting of block A. I need a visual. Alright. Moves the pile of blocks consisting of block A and any block that is stacked above block A onto block B. All blocks on top of block B are moved to the initial position prior to the pile taking place. The blocks stacked above block A retain their order when moved. When A and B are blocks number suppose A is 2 and B is 5, okay? That's a terrible 2. So A and B are blocks number, put moves the pile of block consisting of block A. You know what, let's do this operation on the world first. Move 9 onto 1. Eight over 1. Seven over 1. 6 over 1. Then 8 over 6. 8 over 5. Pile 8 over 5 should do something like this. I could have moved everything at once. So after we do pile 8 over 5, so on to the Alright, let's do the pile onto thing. Moves the pile of blocks consisting of block A where A and B are block numbers, moves the pile of blocks consisting of block A and any blocks that are stacked above block A. Onto block B, all blocks on top of block B are moved to their initial position prior to the pile taking place. Okay, so before we move block A onto block B, we have to reset block B, meaning we have to do that operation, initial state B. So let's just do that. Okay, so initial state B done. All blocks on top of block B are moved to their initial position. Yep, and then move the pile of blocks consisting of block A and any blocks that are stacked in. Now can we do that using put A on B? I mean, this one only puts one block on B, not every stack on B. So we have to fix that. We have to fix this code, then we can use it. So we are searching B and then block world first we need to see what is on top of block B and store every one of those in a vector. Let's do that. Okay. So block A, yeah, let's make a vector. Stack A should be the name, because inside this vector there will be elements that is on the stack of A, including A. Okay. So first we have to find A, and for that we can use this code right here. So I as the length block world. We don't need the flag though, or do we? I don't really know. Let's see, if we need the flag we'll make it. So if iter equal block B, block A, that means we found the block A, so the flag is true. Oh, so we need the flag actually. Oh, flag equal false. Now we cannot define flag twice. We have to remove this initialization here. Then this is gonna work fine. So if flag is true, then are we gonna break from it? No, we cannot break now because we need all the elements that comes after B, including B. So if flag equal true. Then we're gonna start putting those inside the stack A. That push back the value iter, and then after I get the whole stack, and it's gonna automatically get out of this for loop because there is no more elements left. Then I need another if condition. It's gonna say when flag equal true, it's gonna break from this for loop. And before we only pushed A in top of block world I, but now we're gonna push everything that is inside this vector stack A vector. That's gonna do the job. Block I dot pushback point. And now this one, we already know that it clears everything that block world A. Oh no, we have to change that because we only did that as for when there's nothing on top of the stack. That means this guy is inside this index in the vector in the block world. That's why we did this block world A equal clear. But now that we know it not necessarily stays in the same index as the value, it could be staying here, and this is not the same index, so we have to delete this. Yep. Oh, we can use initial state for that, right? Yeah, I think. So after I'm done here, I can just call initial state. Actually, it's not initial state though. I'm just deleting those. I'm not returning to the initial position, am I? I'm just deleting them. So this is not gonna work. I need to make another what do you call it? Yeah, another function for deleting a stack, a particular stack. So I'm gonna call it erase stack, and that is gonna take block world as the parameter and the target stack, for which is in this case A. Actually, I could have deleted those from here, right? Why do I need to bother doing this? So to delete, I used this stuff, right? Yeah, let's do the same thing again here. So now we found on the target here, we are deleting the elements, and as well as we are inserting them inside the stack. So yep, we have to remove this iteration here. Flag equal true, then To erase what I used this thing. Iter equal block world I dot erase iter, else iter plus plus. That should delete the stack easily. I don't have to make another function. That would have been quite a lot of work and a few more lines of code. Now let's see if it's working. Now initially, what is our let's see initially what is our block world. Okay, so initially our world is like this. Let's make it as such. 0 is 0, 1 has 1, 2 has 2, 3. Where is 3? 970. 970. What? Oh, yeah, 0 is empty. I forgot. 3 is empty. 4 has 4, 5. Where is 5? There you are. 6 has 6. 7 has nothing. 8 has 8. 9 has nothing. So initially our world is like this. Now, what do we want to do? Do we want to pile do we want to pile A onto B, like pile 9 onto 4? Let's do that. Pile 9 onto 4. And what is that gonna do? As I recall, it's gonna clear 4. That means 5 returns to its state, and then everything that is on top of 9 will be moved to 4. This should be the next scenario, although I didn't, even if I click this, there will be nothing showing because I didn't print anything. Put A on B. So yeah, after initial state, I need to put A on B, which is block world A B. Yeah, then I'm gonna print my block world. There you are. I could have just written it, that would have been faster. 10, yep, that is our block world. And then when we do pile onto pile 9 onto 4, right? Then our world is like this. Let's see. 0 is 0, 1 is 1, 2 has 2, 3 is null, 4 has 4, 9, 7, 0. Yep, it's working perfectly again. Alright, now for the last one. For the last one, let's see what it says. Where A and B are the block numbers, puts the pile of blocks consisting of block A and any blocks so puts the pile of blocks consisting of block A and any blocks that are stacked above block A onto the top of the stack containing block B. The blocks stacked above block A retain their original order when moved. That means I don't have to clear anything, I just have to move the block A on the block B, which is just this thing, nothing else. I think that is everything. I think we covered everything. Now we just have to print the final block. And that should be outside this hollow, because inside this while loop everything is just the operations. Oh no, that's not it. I want to print the world. Alright, now let's run the sample test case. Oh, I didn't do anything for quit. Like, when am I gonna quit? If the s is if s equal quit, then I'm gonna quit. Break. Done. Let's copy this entire thing. Alright. 0 1 9 2 4 3 5. Wait, what? Where did I go wrong? Alright, it's debugging time. Then I have to print. Put the print here after every operation. Oh, how can I forget? I have to delete these. I don't need these. Okay, let's go to my original state. Yep. Let's comment these out. These were the problem, I think. I think it should work now. What the hell? Oh yeah. How can I forget? I didn't initialize anything yet. Still still not working. Alright, now it's debugging time. I'm gonna put the print here so that I can see every state that is going to, and also an inline after. Alright. We also need our visualizer. The initial state for our visualizer, it should be this. Everything goes back to their place. Now we have 10. Alright, everything's initialized like this. Move 9 onto 1. Now as I recall, if I move 9 onto 1, what's gonna happen is puts block A onto block B after returning any blocks stacked on top of block A, and block B, block A, and block B goes to the initial position, and then puts block A onto this, same as this. Now next one. Oh, I know what mistake I made, because we know that when something like this happen, when pile, like as I recall way back in here, these 8 and 6 were in the same stack. And we know that when they're in the same stack it's illegal here. But we didn't do anything for that, did we? So we have to check for that. Also, when A and B are the same, that is also illegal. Let's do that, okay? So yeah, let's make a function for them to check illegal. It's gonna return a boolean like true or false. If it's illegal, then it's true or false either. Okay, let's just make it check legal. All right. Legal. We have our data structure, and of course our A and B. Now result should be a boolean. Let's initialize this to false first. We can change this if we see if it needs to be initialized true or not. Anyway, it's gonna return this boolean. So how do we check if A and B is on the same stack or not? So for any stack, if the list contains both A and B, then obviously it's on the same stack. So let's do the iteration. So we're gonna need the length of the block world. Got it. Then we're gonna need the, let's just manually write it. Length. And for every list of the vector, I have to find it. So is there any built-in functions to see that if a list contains these two integers or not? I think there is one, but I kind of forgot, so I'm gonna use ChatGPT. Built-in function. In C++, give me the built-in function to find an integer in a list. You can std find. Yep. All right, let's see. Oh my god, that looks like so much work. Find, list begin, and target. What if I take on my list? Is there any simpler way? If you want something simple, contains. Oh yeah, that sounds more promising and simple. Yes, if you want something simpler for checking whether an integer exists in a list, you can simply use the contains. Why didn't you say that to me before? Contains function, but note that this is only available starting from C++23. I think I have C++23, don't I? Yeah, obviously I have. Why wouldn't I? Is that 20? I don't know. Mm, is that version 15.2.0? How do I check if my C++ is uh, 23 or not? Hmm. Anyway, so much for checking the version. I'm just gonna try to. I'm just gonna implement that and see if it works on my compiler or not. So it's just simply my list contains target. If it contains the target, it's gonna return a boolean true, I think. Yep, or one or true, same thing. Otherwise, it's gonna return zero. So simple. So for every vector, I'm gonna check if block world I dot contains, right? Target is A, and I mean if both of them are in the block, then it's in the same block, otherwise it's not. Then result equal false, and I'm gonna make it true, and I'm gonna initialize this to true so that it can become false here and then. So if it's not gonna be false, then it's gonna return true. Simple. I hope it works. I'm already running it. So it's not working. Come on. How do I update my C++ in code blocks? Through CMD or my MSYS2. Got it. You were asking to update your C++ toolchain when using code blocks or MSYS2 Windows, so you can enable C++23. MSYS2 is the easiest way to keep GCC and GitHub up to date. Alright. Now updating C++ component in code blocks. Code blocks itself doesn't include a compiler. it just uses whatever compiler you point it to. You usually min-gw. Update min-gw using msys2 as above. Go to setting compiler, the tool chain executable, point to your new min-gw bin. Oh, I see. I do have the latest G++ 23, but it's not, the code blocks bin is not located to that, I think. Setting compiler. Wait. Come on, man. Where are you? Keep going. What the hell? Oh, it's the total thing. Let me just put it here. And you should be here. Alright. Under toolchain executable, toolchain executables, point to your new min-gw bin folder. Yep. Yeah, of course. Not this one. I know a bin folder it should be in, and that is environment. Wait, come here. Path. Yeah, MSY to min-gw. I mean, MSYS2 keeps the min-gw updated always. I mean, not automatically. I have to type the code first, the command, then it's gonna update easily. So yeah, copy that and then paste it here. Yep, that's gonna solve that issue. Wait, yeah, it's actually the same path, right? The path is the same. It should run now. What is happening? Didn't I update it? Do I have to restart this? What do I have in the untitled one folder? Nothing. Let's just restart our code blocks. Usually when you update something, it requires a restart. So that's what I'm doing. The block problem. Let's try running this now. It's not working. Did it update though? All programs must exist either in the bin subdirectory or this path or in any other. I mean, the programs exist in this path. So what seems to be the problem? It's GCC compiler, right? I don't know what am I even looking for here. You know what? How do I update my MSYS2? Oh, that's not the thing. How do I update my min-gw? I mean, I'm actually updating my C++, right? How do I update my C++ to 23 through MSYS2? Main GW. Oh, GCC 13 plus supports C++ 23. I already have that though. Yeah, it's 15. So obviously it has C++ 23. I don't upgrade anything. It is still updating a lot of stuff. Yeah, do that. Let's go to the path environment. Main GW bin MSYS2. Where's my code blocks? Here, right? Main GW. Bin. So it's program files, code blocks, main GW bin. Program files, code blocks. Okay, no, nothing. Program files, code blocks. Nothing. It doesn't exist. Min GW. What if I delete this one? I don't need it, do I? Let's restart the code blocks. Yeah, let's hide this. Working. Did I do something wrong here? Yeah, block world I has a list inside, right? And if it contains it's not working. Class std list int has no member named contains. Now why don't I give this to our fellow ChatGPT and see what he says. Cannot even copy this. Alright. Wow. There is no target, no project, compiler unknown. List has no member named contains. Yeah, exactly. It means that your compiler on code blocks is not C++23 mode, it's compiling in an older standard C17. That's why it's not working. No, I don't want to do this. Go to setting compiler. Compiler. Under the other options box, where is that? I mean other settings. Yeah, my GCC is 13 plus. It's actually 15. So under other option box, add compiler. Under the other option box, where is the other option? I think this is the other option. Rebuild. Still not working. Where am I? The blocks problem. Still not working. You know what? Forget this. I'm gonna run it in Visual Studio. Alright, Visual Studio, don't disappoint me. But oh yeah, no member contains. So what if I remove this? Is it gonna run? What happened? I want to comment this. Did I also comment this one? No, it's the same color. Oh yeah, I have to run it like this. Yes, probably. Whatever. What happened? The blocks problem. Active file terminated. Do you have to delete these two? Oh, now it's working. Is it? Oh, so that was the problem. Yeah. Let's see. Now how about if I uncomment these? The same issue. So it's saying that has no member name contains GCC class, has no member contains C plus 135 quick fix. Add include flag set include. Now tell me if it's C++23 or not. So J15, that's way beyond GCC13, so it's definitely supposed. Yep, that's what I'm saying. So why isn't it working? So how do I change it in VS Code? Oh yeah, JSON. Install C++ extension by Microsoft. Open your project folder. Create or edit VS. Create or edit. Where can I find it? Mm, oh yeah, this one, right? Configurations name Win64. Where's the compiler path? Name, type request. There is no such thing as compiler path. Standard. I think this is not the one. Where do I find this JSON file? Still not working. Even after all this, it's still not working. It still didn't work. Guess I can't use it then. Let's do it manually, okay? I think I'm too tired because I am not finding the strength to talk. I mean, to explain. Yeah, that should do it. Now let's try running that again. What? Now where's my debugger? Yeah, I created the function, but I haven't used it, have I? I have to use it. So before I go to the conditions, if a legal AB, then I'm gonna go to the operations. Otherwise, I'm not going to the operations. There you go. Now let's try running that again. Legal. Oh, if legal. Oh yeah, block world is also a parameter here, so I need to put that. That didn't work, I guess. Wait. So if it's illegal, then it's returning false. If it's not illegal, it's returning true. Oh, wait. Plus plus. Oh. Total 00 should be in here. that should work now. Finally. 01924358876. Yep, our code is working. That took a long time. Now let me clean this a little bit. Let's take this guy out too, and I don't need you. And you're supposed to be outside this while loop. Right here. Oh, what happened? Did I do something wrong? Oh, why is there end line here? Oh, this guy needs to go. And what happened when I had this one? What? I can't use this one, can I? I have to delete it. I don't need that anyway, so. Yep, working perfectly. 240 lines of code. Wow. I mean, I can make it smaller, but that's gonna take a while. Let's try submitting this. Please be right answer. C++11. How could I have used contains? It only takes C++11. Please be accepted. Alright, that's it for today. I'm gonna solve it tomorrow. I don't know what went wrong, but I'll find it.